Thus far in our work with trigonometry, we've always used right triangles, whether it was a special right triangle or we used right triangle trigonometry to solve for a given side or possibly an unknown angle. Now we're going to venture out into the real world where not everything works in right angles. So we have what is called an oblique triangle. An oblique triangle is any triangle that does not have a right angle. So we're talking about non-right triangles. Non-right triangles are called oblique triangles. Now, to solve an oblique triangle, you need to be given some information. But what does it mean to solve an oblique triangle? To solve a triangle, we would need to find all of its parts. And any given triangle has 6 parts. It has 3 sides and 3 angles. So to solve a triangle, you need to be given 3 out of the 6 parts. If you have 3 out of the 6 parts, you can solve for the remaining 3 parts. However, you can only solve for the remaining 3 parts if the first 3 parts they gave you were certain parts. So that's where number 1, 2, 3, and 4 come in. If you were given 2 angles and a side, whether the side is included or not. So an included side is a side between 2 angles, and a non-included side is a side that is not between the 2 angles. I'm going to draw a picture. That would be number 1. Number 2, if you're given 2 sides and an angle that is not included. An angle that is not included. Number 3 is 3 sides. If you're given 3 side lengths, you can find the remaining 3 angles. And number 4, if you're given 2 sides and the angle between those 2 sides, you can also find or solve for the rest of the triangle. Now, the reason these are broken up the way they are is because the first 2 ways require what we call the law of sines. It's a formula. And if you're given 2 angles and a side outside those 2 angles, or 2 angles and a side between those 2 angles, or 2 sides and an angle outside those 2 sides, that's called law of sines. So we would use law of sines. If you're given 3 sides, so if you're given all 3 side lengths, if you're given 2 side lengths and an angle between, we would use what is called law of cosines, and law of cosines is going to be in another lesson. So this lesson is going to focus on the law of sines. Both of them are very handy. They're used out in the real world in construction all the time. For instance, when they're building roads, when they're just determining water flow on streets so that when it rains it doesn't get flooded, everything angles down towards the sewer. Building buildings, where to put a building, where to put a corner, where to put a curb, all of those things, how to measure a distance that you can't necessarily get to. So the distance maybe from one side of the mountain to the other side of the mountain, but you can't go through the mountain, obviously. You can measure the width of the mountain using the law of sines. Lots of different areas that you can use and that the law of sines is used in the real world. Let me draw an example of each one of these situations. So an angle, side. Now these aren't 2 triangles that you're proving are congruent, are similar. This is one oblique triangle. If you have 2 angles and a side, so if you're given an oblique triangle, obviously no right angles. Let me use my straight tool here. So that's obviously not a right triangle. I'm given 2 angles. So they give me 2 measures of 2 angles and the side outside of those angles. So it's going to be either that side, or it's going to be this side. Either one of those sides is a side that is not included. It's important because I'm going to use that language, and it's from geometry. So hopefully you got a little bit of that language from geometry. You can also, I'm going to draw a picture, another oblique triangle. It's not very big, but it's oblique. You could also have the two angles and the side included. Okay, so let me draw angle, angle, side. That's going to be this one on the left. That's an example of what that might look like. An angle, side, angle. The side included is the one on the right. If they give you two angles and a side, and that side is either included or not included, you're going to use law of sines. That's what this means. In number 2, and I can keep drawing the same triangle. And typically I do this way. I don't mess up and draw a right triangle. Sometimes your brain wants to draw a right triangle because they're beautiful things, those right triangles. Two sides and the angle. So if I choose that side and that side, any two sides, it doesn't matter. Now the angle that I choose cannot be the one that's between the two sides. It's got to be not included. So it's either that angle or it is this angle. So either one of those would be two sides and a non-included angle. The included angle, I'm going to draw it and then erase it. The included angle would be the angle that is between the two sides. That is not where this A is. This A is not between the two sides, therefore it's the not included angle. So number 1 and number 2, remember, those are law of sines. Let me change this color because I want to be consistent. I used red to say law of sines. So I'm going to do that here. If you are given information that fits into number 1 that makes your triangle look like number 1 or 2, not picturesque, but angle, angle, side, angle, or side, side, angle, that would be law of sines that you would be using to solve the triangle. If you are given 3 side lengths, so you've got an oblique triangle and they give you all 3 side lengths, you could also solve for the unknown angles using what we call law of cosines. Two sides and the angle between would be side, angle, side, and we could solve for that triangle using law of cosines, and we're going to learn law of cosines in another lesson, so we'll learn that elsewhere. So this gives you kind of a basic as to where we're going, solving triangles that are not right triangles, and hopefully what it means to solve a triangle. If you miss that and you don't know what it means to solve a triangle, it's so important that I'm going to write it down. What does it mean to solve a triangle? What does it mean to solve a triangle? I would rewind the video, maybe listen in the very beginning where I explain that. Every little thing that I'm trying to say here is really important, and that's why these videos will be hopefully helpful for you, because you can rewatch them over and over and over again.